Hello and welcome to the continuation of the Category L7e Hybrid electric vehicle. So in the previous videos I made a model out of straws and hot glue, which simultaneously with that I captured it in 3D with PyOpenSCAD, which is a Python object-oriented wrapper around the parametric, a parametric object-oriented wrapper in Python around the parametric OpenSCAD, which is quirky, obtuse, and basically unusual. It's attempting to be a programming language without having the expertise of a decent programming language. So by using Python, which is known by 1/3 of the world's programmers, we substitute and compensate for that lack and use the best abilities of OpenSCAD with the best abilities of Python. So what I've done here is taken a screenshot of one of the pieces. This is the bonnet, and constructed it from in bamboo at full size. And I'm going to have to lift the thing up there. So it's 1.4 meters wide by 1.2 meters long, what I did was I wanted to get an idea of a feel for how things would turn out without the nodes, and just sort of putting all the pieces out, all the pipes, and see how things would go. Now you can see in the middle of each of these things here, you've got these nodes. These nodes are missing here. That's literally just taped together with packing tape, and this is not going to work. Sigh. So this is very much a sort of an experimentation phase at the moment of what is going to work. I thought about getting some 50mm spherical polystyrene balls to put in the thing, because these here are 50mm from that there to there on each of those nodes, with clearance for the nodes, as they're called. But that's not going to work. So what I'm going to have to do is redo those nodes properly and get them 3D printed. And there's 20 in this one shape alone. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, which is 1920 is there. 1, 2, 3 here. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, collapsed on the floor, 18, 19, 20. I've also printed out the locations of every single one of these and coordinates from the front center position there. Front and center is actually 55 centimeters up. down, sorry, from here. And the reason for that is because I'm going to have to assemble a support jig. That's the other thing that this experiment here showed, is that this isn't going to work without a support jig on giving the exact positions of each of these these nodes. Even if we rely on the accuracy of the nodes and the accuracy of the pipes, the geometric geodesic shape of this is such that it could be even like 1 millimeter will result in 1 millimeter out on the length here would result in pulling that, which would twist that, which would, yeah, it's just not going to work. So we're going to have absolute positioned jig things on a flat sheet with triangulated rigid uprights that each of these nodes sits on in order to have their positions correct and absolute. Now, by the way, this is a standard technique. Nodes and pipes, there's actually apparently you can get, there's a geodesic hexayurt dome kit that you can get on eBay. You can buy 3D printed nodes exactly in this technique, 3D printed nodes, and fit some PVC pipes together, and you end up with a geodesic tent, basically, that you can then cover in whatever fabric or whatever it is that you want. Kids' toys, the similar sort of thing. You can make out of wooden things. You can make it's another thing. It's just that in this particular case, every single one of these is unique, so they have to be specially 3D printed and numbered. You can see I had to number every single one of these pipes. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then went into the cross ones. 10, 11, 12, 13, 14, 15, 16, 17, 18, and here's what's really nice is that I recognize these numbers. They are exactly the numbers that I used in the construction in the Python program that actually lays them out. So there's 61 pipes in here. This is not a small project, and that's just for the bonnet. Now, why PVC pipes? Because they're dirt cheap. They're something like 60 cents a meter or 60 pence a meter, which, given that I'm going to need probably about 200 meters, starts to get into a hell of a lot of pipe. So I've picked 19.5 millimeter Flowplast PVC waste pipe, and I'm going to cover them in Kevlar. Kevlar cloth. This is a 4 millimeter weave and weft. So it's basically it's a 1 millimeter thread, and there's some more of them. It's a 1 millimeter thread, right? Which gives you a 1 square millimeter hole, and a 1 millimeter that way, and a 1 millimeter hole, and then a 1 millimeter that way, for a total of 4 millimeters in both that way and that way. And what that means is that the resin can go straight through. It's not a problem at all, and I am absolutely astonished at how strong this is. It's 3 layers wrapped. Here's some of the failures. I tried to put it down the middle of I tried to push with a dowling rod. I tried to push the PVC pipe on the thing to get it on the inside. Waste of time. The dowling just won't come out. The resin soaks into the whatever material you put on the inside to try and get the dowling out. Yeah, not having it. So the idea was to have these bits poking out that would then go wrapping around the node pieces, so you'd have pipe with Kevlar cloth and thing, and then be able to think. But then I just realized, what the hell, you might as well just wrap it on the outside rather than on the inside. This was another experiment where what I tried to do was to use construction foam to shove that down the middle, rather than using resin, just shove sort of thing. The string snapped off the end side as I was pulling it through, and again, it was just wasting time, unfortunately. But hey, I say wasting time, I mean, I made an experiment before ending up spending a hell of a lot of money, and found something that would have wasted a lot of money. So anyway, let me see if I can. There's the camera. These are 12.5mm pipes with 3 layers of wrap resin. You would know the technique as fibreglass, but or carbon fiber, but this is, instead, I'm using Kevlar cloth, because again, it's nice and cheap. It's cheaper than carbon fiber and easier to work with. I am, again, absolutely astonished at how that's quite a lot of force, and it's flexing maybe 1mm. And these ones, just incredible. So I'm pretty confident that will give a lot of strength there, just from 3 layers. And yeah, these pieces end up wrapping around these 3D printed nodes, and then you can resin those up and then start wrapping, just like in Calfee Design. If you look up calfeedesign.com, this is exactly the same technique that he uses. You put the and your node will be in the middle of that, and then split these so that it comes out, and you can join from there, and then some more strip, Kevlar strip, just wrap, and you fix the node as a frame. Now, it would be really nice to have something in the end of here, some sort of aluminium or metal or strong steel, carbon steel thing in the end here, which into the node, which would be cast. You just go clunk, chunk, click, and that into the node, and basically assemble the entire thing in half an hour. This was the technique that Kevin from Divergent 3D Microfactories came up with. And so he's using carbon fiber pipes, and these are 3D printed metal. All the nodes are 3D printed metal, and so fitting together a frame that's only 30 kilos using the Divergent 3D Microfactories technique is half an hour. 30 minutes to construct the frame for a vehicle that's only 30 kilos. Absolutely astonishing. This will be similarly light, but repair and initial construction is going to be a pain in the ass. But yeah, I'd need a metal 3D printer to be able to do it. And the idea of this technique, this construction of this vehicle, is you can literally construct it in your kitchen. Here's the garden. So the idea is that you'd literally be able to build this the frame in sections, in a DIY environment and safe things, so there'll be no hazardous materials, no hazardous tools, no power tools used inside the house, no industrial power tools, etc., etc. It's all going to be made from DIY craft materials and plumbing parts. Now, well, that's the diesel generator, by the way. I just wanted to show you this. This is going to be the body panels are made from. So, in between here, covering over here, I'm going to make a frame like this. So if I can bring that, this is the front of the bonnet. This is the front. So basically I'm going to construct a compound curved shape. I very deliberately created a jig which has compound curves on it in 2 dimensions. And having done this jig, I then laid more of these. These are craft, DIY craft 9x1mm bamboo pieces held together with hot glue. Works really remarkably well. I then made the actual lattice frame on top of this, shaping it up, and then using polyester from fabric that you use to recover sofas, stretched and hot glued that on, covering you can see where the wood is from the bamboo is from the thing. Now that's 3-4 layers. It's 1 and 2, and fill in the middle pieces, and then 3 and then 4. So it ends up being about a centimetre, about 9 or 10 millimeters there. And what I did was I took one of those, you can see the barbs. It's one of those barb guns, and those very specifically got 12mm ones, and went ka-chunk, 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 ka-chunk all over, and then filled it up with construction foam. And we'll clean it up afterwards. You can see whether it's ended up going through, and that's where it was leaking out all over the place. So I did an experiment, the Mythbusters golf ball dimple there. That's actually a milk bottle top. I decided not to bother with that. Instead, I realised that you could actually use the plastic barbs themselves, and they would pull it down and create a dimple, which would give you the turbulence needed to create a boundary layer effect. So I don't have to do this at all. This is too much work. I'm messing about. So it looks like I'm being lazy on there, but it's not. There is actually a reason, a purpose for having these dimples. It just happens to be coincide with being lazy. Isn't that nice when it happens? Don't worry about the inside, not worry about the inside. But I'm just absolutely astonished at how light, but also how sturdy this really is. And imagine you get a stone hitting this, gravel, etc., etc. It's going to bounce. It is because it is construction foam. It is slightly compressive. It can actually compress slightly, which is good, which means that unlike a vehicle using a steel body, it's going to ping off and potentially cause damage and chipping, etc., etc. This, it's polyester. It's really cheap. If it gets damaged, we don't care, we just patch it with another piece of cloth. Which this was the whole thing behind geoboats.com. Geodesic aerolite boats, absolutely fascinating website the guys made. Well worth looking at. It's remarkable. He managed to construct a 9-foot by 2-foot canoe weighing only 4.5 kilos, 4.5 kilograms, from green ash lattice slats, Dacron, aka polyester, Dacron sailcloth, the pretty strong stuff, hot glue strips, and Kevlar twine, very strong Kevlar twine, just to give support. And you have to make a jig using ribs thing, but it's absolutely remarkable, and a similar technique. So very hopeful that this will work out well. So thank you very much.